Okay, so let's keep going with our reactions then. So looking at oxidation, I find the easiest thing to do first is probably not so much work out the terms first, but work out the two reactions. So let's just, I'll just remove these headings just so it makes it a bit easier, if I can do that. There we go. Okay, so let's just have a think about what's going on. So lithium obviously is changing because we've got lithium atoms on this side, but over here we've got a salt. So here we've got metallic bonding on the left, and we've got ionic bonding over here. So that's a change. So the lithium atoms have changed. So we started with lithium atoms, and we produced lithium ions. So in order to balance that, I've got a charge of 0 on the left-hand side. I've got a charge of +1 here. So I have to balance that. So the way I balance it is by putting a negative here, because obviously 1 negative plus 1 positive makes 0, and that's 0 on the right, which is 0 on the left as well, so that's balanced. So that's our first reaction. Our second one is obviously to do with hydrogen, same as the previous reaction. So we've got hydrogen ions grabbing an electron, and that produces hydrogen gas. Now to balance that, we've got 2 hydrogens on the right, so we need 2 hydrogen ions on the left. And to balance it further, we need 2 electrons to make sure the charges on the left add up to 0, just like they do on the right. This is the point now where I work out which one's oxidation and which one's reduction. So I go through my oil rig. Oxidation is loss. So that's on the previous slide. So I have to think about which one's losing electrons, and it's the top one. Okay, so this is my oxidation reaction. And therefore, the other one must be reduction. But to confirm that, I'll look at the fact that it's gaining electrons, and reduction is gaining electrons. We often refer to these as half equations because they show the 2 reactions that are going on. One substance will be gaining electrons, that's one half of the picture, and the other half of the picture is that another substance will be gaining electrons. Now you might have noticed, I'll ask what the spectator was before I go into something else. So the spectator would notice that the sulfate ions remain unchanged. So in this reaction, the sulfate ions are spectators. They're not involved in the reaction. Just going to extend that page a bit just to try and look at the overall equation. So moving on to something new now. So what we can do is we can actually add these equations up to work out the overall equation. So what I do is I'll look at my 2 reactions. But before I actually can add them together, I need to check that both of them have the same number of electrons. Okay, you can't actually add the reactions together if you can't account for all the electrons. So before I add them, I need to do something with this first one because I've got 2 electrons in the second reaction, but I've got only 1 here. So what I do is just go through and double everything so that it's the same number of electrons, and now I can add them together. So on my left, I have 2 lithium atoms, and I have 2 hydrogen ions, and I've got 2 electrons. That's my reactants. Okay. My products are 2 lithium ions, hydrogen gas, and 2 electrons. And if I've done this properly, I should be able to cancel out my electrons. So 2 electrons there, 2 electrons there, they cancel out. So my overall net ionic equation is this. 2 lithium atoms plus 2 hydrogen ions produces 2 lithium ions plus hydrogen gas. So notice there's no sulfate in that equation. The reason there's no sulfate is the sulfate is unchanged. It doesn't change. It's not involved in the reaction. In an ionic equation, we only include the substances that change. We don't include the substances that don't change. So that's the difference between an ionic equation and an overall equation. So overall equation would be the one we had in the previous slide. I'll just highlight that again, which is this one here. This is your overall equation. That's your overall equation that we looked at earlier. Whereas what we just looked at just now, is our, what we call net ionic equation. So it's just these substances that change. Okay. I think that's all I need to say. So I'll pause that there.